Hey all, Tom here from Made on Jupyter with a little demo of Spoke Creator, and more specifically we are going to look at how we use events in Spoke Creator. I'm using a little file here that is kind of a work in progress for WikiHouse. Check out their website at wikihouse.cc. And what we want to show is how to use events to kind of optimize the interactivity in a file. So let's have a look here and start manipulating the WikiHouse frame. This works quite nicely, and there's a lot of parametrics happening in the background here. But as you can see, even at this stage already, and it gets way more complex beyond this for WikiHouse, it's already getting a little sluggish. And so, well, there's no way around that. That's the way parametrics are. It does get pretty heavy pretty quickly. So we can use events to try and optimize the interactivity in this file and keep everything pleasantly fast and snappy. So let's go and look at the parametrics here. I don't want to scare you too much. This is the current state of the WikiHouse parametrics, and I'm going to change a couple of the connections here so we can have a closer look at what I mean by events. So now when, for example, I move a point here, it only shows me what's truly important and hides the rest. For example, another example is when I change the length of the house here, it gets rid of some of the elements that we don't really need to evaluate the length of the house, and you can see it is way faster. And I think I have a third event here that I'm using to speed up things. Even, you know, on some slower computers, this might be a little sluggish. So I have the shift key here to actually hide some of the internal complexity so that the user can work with this in a way that's pleasantly fast. So we've looked at three events here. We've looked at an event that is driven by a value change. We've looked at an event that's driven by purely editing a point here. And we've looked at an event that's driven by hitting a key. And all these events and more can be used to trigger things in the parametric network. So let's have a closer look. Let's maybe first look at the editing event. So when we move this point here, you can see that the rest of the struts here disappear. And that happens through this kind of generically named event node, which currently has only one output. We'll add more to this node as we go, but this is kind of the general purpose event node that doesn't correspond to anything that we generally know, like keys or mouse movements. So this particular one looks at whether or not the user is using any kind of editing in the view, any kind of Spoke specific editing tools. And it spits out a Boolean that we pass onto the switch here. And if you look at the two things that come into the switch, so we have a single, what to call it, this is a strut. And then we have the copy node, which copies that same structure by a certain number of times. Of course, that copy operation gets a bit slow if there is much geometry coming into it. So essentially what we're doing is switching between one and all copies based on whether or not the user is editing the contour here of the house. So that's what's happening here. Then we have, let's look at the one that's defined by the length of the house. When we move that value here, we can see that it's hiding some of the detail in the curves, the white lines, to keep things a little faster. But we are keeping anything that's required to see the actual length of the house. So how does that happen? Well, that happens through something called a value changed node. And the value change node takes any kind of value. It can be an integer, a float, string, anything that can change in scope, and there's quite a lot of things. You can just plug it into the value change here, and again it spits out a boolean that we then drive a switch with. We're doing it for two values here, the number of members. Here we're actually removing even more geometry, because the only thing we need to see is the number of verticals there. And this allows us to, again, have very good performance as we change the value and get behind it that value. So same way, we are listening to that value, and that spits out a boolean based on that, whether or not that value has changed over the past frame. And here we're doing a little trick. We're adding these two booleans. This boolean is 0 or 1, and this boolean is multiplied by 2, or is 0 or 2. And so this switch has three inputs. The first one corresponds to a switch value of 0, which is a default when there's no events whatsoever. And then we have two other nodes coming in. So if we look at this one here, this is the first geometry. Actually, no, this is the first option. This is by default, everything is in there, the curves and the side panels, and then we have a little more simplified without the curves, and then we have a collect here. Oh, sorry, this guy here, which is just one of the probably just the front panel of that structure. So again, the switches between three options based on whether or not the index input here on the switch value is 0, 1, or 2. When it's 0, there's no events. When the length of the house changes, this value, this index becomes 1, and when the number of members changes because it's multiplied by 2, this gets added up to a value of 2 and it switches this to 2. So that's how this works. And then the last key event that we were looking at is the key input. And the key input switches between a simple and a more complex set of the curves. This more complex one is based on this joint spacing and has some fairly complex parametrics inside here. So we cut that out for faster performance. Again, we have probably for a value 0, we have the default and everything in. For a value of 1, we have the simplified version. We put that in the switch, and the switch gets switched based on a key event. If you look at the key event node, it has, you can set it to any key you want. We have the left shift here and the right shift here. So it will listen to both left shift and right shift. These both get piped into an OR node, so this will spit out a true value, or a value of 1, when either of those are pressed, or one of those is pressed, and switches the switch to the simplified mode. When I press Shift, this switches to the simpler mode and gives us better interactivity downstream here. So that's how it works. So I'll show you again. If we edit, the editing just hides the other structure. Only shows you one. Then the length of the house removes the curves, which kind of slow down the copy. The members hides even more, so you can add lots of members and still stay fairly interactive. And then the shift key works in conjunction with all that to speed things up even more when you have curves visible.